Welcome back, everyone. We have an update from Cyngn Inc. It trades on the NASDAQ under the symbol CYN and develops and deploys scalable, differentiated autonomous vehicle technology for industrial organizations. Cyngn's self-driving solutions allow existing workforces to increase productivity and efficiency. And the company addresses significant challenges facing industrial organizations today, such as labor shortages, costly safety incidents, and increased consumer demand for e-commerce. We'll be getting that update from the VP of Business Development, Ben Landon. Welcome, Ben. How are you today?
I'm doing well. Thanks, Anna.
Great. So what role does artificial intelligence play in object-based recognition and detection?
Object recognition, detection, classification, all of these terms that often go hand in hand are part of what's known as the perception module within autonomous vehicles. So perception means taking data from sensors and actually creating some intelligence, some insight out of that data. So this is actually the module within the autonomous vehicle stack where artificial intelligence, as we speak today, deep learning specifically, is, let's call it, the most proven in terms of applications of AI in autonomous vehicles. This is where we saw machines start to beat non-AI approaches and even humans over the last several years, and it dovetails in with the advancements we've seen in computing capabilities, CPUs, GPUs. But so that's where we really apply quite a bit of artificial intelligence. It lets us get to that additional level of not just, hey, there's a thing out there that we must be able to navigate around, but what is that thing? According to what that thing is, because it's in my artificial intelligence object vocabulary, what does that mean I can expect from it to do? Do I have special rules about how I engage with that thing? Is it a forklift? And I want to always stay at least some distance away because we don't want forklifts move in odd ways and dangerous ways, and we don't want to jam up something needing to do a multi-point turn, and we're right there too close trying to get around it. And then you're sacrificing the throughput that you otherwise would have promised would come from automation. So that's really where it all comes into play. And then we have additional layers of our perception stack that back up that very rich AI layer that gives you that level of intelligence. So we have non-AI layers that do the work for us when an object falls outside of our vocabulary or where there is something unexpected to say, hey, there's an obstacle there. I don't know what it is. We need to be able to navigate around it. And then all the way down into what we call our virtual bumper, which is basically a proximity emergency brake as a last resort.
Okay, well, thanks for explaining that. So what human inputs are required to enable vehicles equipped with your technology to operate safely? Has AI developed to the extent that you can truly leave them to make their own decisions?
This is where I think that there's a lot of misconception out in the world about what AI is and what AI isn't. So we can use AI to resolve situations, for example. So we can trust on, and sometimes it is an AI contributor, sometimes it's not. Like I just mentioned before, AI is a tool. It's not necessarily the only tool. And our goal is to apply AI in a way that makes our products more useful, our solutions more useful, not to find a way to cram as much AI as possible down our customers' throats. So when you look at what can you do, there's, for example, planning a path can be very straightforward, right? If you're walking down a straight hallway and you want to get from one end of the hallway to the other, you don't need a super sophisticated algorithm to tell you go walk in a straight line down the hallway. Those kinds of situations exist, and that can be the baseline of a planning system. But when you run into kind of weird corner cases where it's not as deterministic to solve the problem, you can't just do A, then B, then C, and the problem is solved. That's when you can start to lean on a little bit more of learned methods which in other words means AI, to start to see how these types of situations were dealt with in the past, and then start to address them in a different way. So that's where AI lives. And the reality of how the world uses AI today is that it's still narrow AI, meaning that we can make AI, train AI to be very good at solving a particular task. But this is the whole point of our system. It's to let humans do the jobs that they need to do at work. So The AI as we know it in the world today is not going to say, okay, I'm now here at your manufacturing facility. Just feed me data, and tomorrow I will tell you how to optimize everything, and humans won't be needed here anymore because I'm AI and I'm here and I figured it out. So that's why we have our Cyngn Insight tool suite. It's for people to have simple software tools to interface with this really complicated AI and robotic system that's all embedded in the vehicle. But to you, the human who knows, this is how my workflow goes, this is where I need to move things. A huge order just came in that I need to escalate beyond just the first in, first out of my warehouse management system or my ERP system. That's what we need from the human, because they know their business the best. And then once they give that task, then we have a variety of systems, AI, non-AI, that can go and solve that for them with as much of hands off as possible.
All right, that makes some sense. Let's talk about self-driving cars and robo-taxis. They have definitely had some undesirable behavior documented in the past, created some traffic issues in some cities, and even caused accidents. So talk to us about Cyngn's technology and how you are ready for prime time.
This topic, I think I mentioned last time I was on, is near and dear to me, since I come from the world that is robo-taxis, and Tesla acquired my last company, which is probably what's behind the question here when some of the undesirable outcomes that are often in the news are mentioned. This is part of the strategic reason why back in 2016, we said, hey, robo-taxis are doing some great things from a technology standpoint, but there's a gargantuan problem in front of them in terms of being able to operate safely under all the conditions that can occur in the open world, where you have very little control and practically everything under the sun can happen. So what we did was we made a strategic decision years ago to build the system as closely as we could to how a robotaxi is built, meaning using the best sensors, using a subset of those sensors and those computers, because we don't need to see as far. We don't need to solve problems as quickly, by nature of deciding that even though we would build like a robotaxi, we wouldn't necessarily have to deploy our product in the same arena as a robotaxi, meaning that we went and built robotaxi-like capabilities. And then we went and focused on these industrial domains, where instead of driving 40, let alone if you're doing highway robotaxis, 70 miles per hour, you're driving maybe 2 to 5 miles per hour. Instead of driving around crazy city streets and needing to look out for kids jumping behind cars and all the endless amount of corner cases that can happen out there, we only deploy in closed sites that our customer trains anybody who interacts with the vehicle, who are there getting paid to making their livelihood by working with the vehicle. And that, I think, was an important and differentiated approach to the problem that now puts us in a place where we are ready for prime time by nature of reducing how ready you need to be for prime time. We don't have as big or as dangerous of problems to solve. We can slam on the brakes when we have just a brand new unknown situation we've never ever seen. We can just slam to a stop and go from 2 miles per hour to 0 miles per hour in some corridor of a manufacturing facility, which you cannot do on the freeway when you can't go into panic mode and slam on the brakes when you're not sure what to do. So it's a hand in hand. Have the technology ready enough. We're very proud of what we've built. Like I said, we're bringing that robotaxi level into the industrial sites. But by nature of narrowing the solution to industrial sites, we shorten that horizon to when can you really be ready? And I hope that's what kind of lets us have our cake and eat it too, as we grow over the years past industrial, because our technology will continue to develop and we'll have carved out some success in these domains that we focused on in the short term, while we continue to see billions and billions of dollars being spent chasing the pod at the end of the rainbow of robotaxis without them having the strategy to create other successes along the way.
Well, continuing that thought, Harry Marshall wants to know, how far from mass adoption is your product?
We're mass adoption now. The difference for us is for the release product, for example, DriveMod, the DriveMod enabled stock chaser, which is commercially released. The difference between where we are now and mass adoption is sales. It's not R&D. Beyond that, it's replicating what we spent the last, call it 18 months or so, with the Columbia Vehicle Group and with our DriveMod patent and the release of that DriveMod kit patent for the stock chaser into a mass production scale. It's repeating that now for other vehicles so that we can achieve that vision that we had, which is essentially a universal industrial autonomy system. So that not only is the difference between mass adoption and stock chaser sales, but fast forward a little bit, the difference between mass adoption for forklifts, DriveMod enabled forklifts is just sales, and DriveMod enabled tow tractors is just sales. And then we have really the product suite that we've been targeting under our enterprise autonomy suite, the EAS system that is our product, that has this entire portfolio of different automated vehicles that a customer can just say, hey, I'm ready for this one, sign me up. I want a combination of these 2 or these 5. I want them all running at these facilities. And that's how we see this, this kind of adoption of each vehicle, along with adoption of the entire suite of the vehicle products.
So that leads to Ben Mimek's question. Do you have commercial products in the market now in the moment, or are you still in development mode?
We do have commercial products in the field. So the one that we have mentioned publicly is the deployment that we have of autonomous stock chasers at US Continental, which is a California-based manufacturer of chemical and fabric care materials. So that's the one that we've mentioned that we've deployed that's out in the field. Where there's, let's say, additional similar activity, none of which has been mentioned yet. And then we have made our first announcements towards some of those next vehicles that are coming, the forklift being one of them. There's still a bit of a delta of repurposing the DriveMod that is our DriveMod AV stack that is released on the stock chasers, repurposing it for the forklift. It's something we've done on more than 10 different types of vehicle form factors over the last 5 years while we were in more of a stealthy mode. So it's something that we have a very high confidence of doing at this point, which is why we have a customer willing to pay us to do it. And that's our plan for the next year and beyond, is to get more of those vehicles available alongside the stock chaser to be commercially deployed, and then continue going into sales mode across more and more vehicles and deploying more of them.
Great. Last question from Carson Hobbs. What's your biggest challenge?
The biggest challenge is still that it's still a fledgling technology. We're still in the adoption, the customer adoption curve. We're definitely still in the early adopter phase. Now, I will contrast it from when I got into autonomous vehicles 7 or 8 years ago. There are some great positive differences. For example, back then, every one of my pitches was educating customers why autonomy was coming and that it was important and that the wave is here and it can happen. It's a reality. I think the world has come around on that at this point. I have folks reaching out to me, potential customers, partners, who come from organizations that you would not think were on the leading edge of knowing what was going on in automation or autonomous vehicles. And almost all of them now have directors of automation, and they have entire initiatives that do things like link electrification and automation, and just all of these really large macro trends that we know are going to change the way that business is done for the better. They now reach out to us. They don't need to be sold on what can automation do, what is it. It's more of a, what exactly do you provide? How would I adopt your solutions? But it's still that early adopter curve where there's a whole lot more people still to get to. There's still folks sitting saying, I'd like to see the real early movers do it before I do it. And so it's that to stick with that adoption curve analogy. We're at that crossing the chasm moment of how do we get from the folks who have known and are tinkerers or true believers in automation, how do we get past saturating that stage of the adoption cycle and get to the everybody out there where it's just the household name and the everybody's doing it type of thing, to just get, every vehicle that's getting out there is sold. The last data point I saw was the material handling space that we work in. Less than 1% of the vehicles that are shipped per year are automated. So it goes to say, in spite of all of the excitement, in spite of the knowledge that it's coming, we need to accelerate those buy decisions.
Right. Well, it's all happening in real time. It's an exciting time. Ben, thank you so much for joining us with this update, and come back again real soon.
Thanks for having me.
All right. Stay with us, everyone. We'll be right back.